What is it? The metal sheet? So you bent a long metal sheet that's 45 cm, 600 cm, right? What are you trying to make? I'm trying to make a cover. So, you made some kind of pathway, like a channel for water to flow, like a drainage channel. So I made it like this. Is this right, guys? What are we supposed to find in this problem? So, what are we actually supposed to find in this problem? Are we supposed to find something like that? First, it says to find the angle of 2.08. But as we can see, guys, the initial length of the metal sheet is 45. Then, if we add this, this, and this, it equals 45, and this part is 10, right? So, obviously, what's left here? It should be 25, right? So, if you add this, this, and this, it equals 45, and here is 10, right? Then obviously, what's here? It should be 25, right? The length on the left here is 10, and the length of the arc is 25. So when we're finding this angle in this sector, if it's in radians, we can find it using the radius, right? Is that right? So you can find this directly as 25 over 12. That's right, guys. So what do we need to find next? Are we finding the area? This area? How do we find this area? How do we find the area? First, I think we need to find this one. There seem to be several ways to calculate this area of this rectangle. Adding this area, it looks the best, right? So we need to find this first, but how do we find it? Radius times radians. Is this 25? Yeah. How does this look right now? What's the length of AB here? Should it be theta? It's 2.08, but since we know 12, 12, we can solve it using the cos rule. Or you can calculate it this way too. If you split it in half, you have a right angle here. So since it's divided into 2, it's 1.04. Therefore, when you find this, you can calculate it as 12 times the sine of 1.04 and then multiply by 2. That's fine too. Both methods are fine, guys. You can use a right triangle. You can use the cosine rule. So anyway, after finding this length first, we're trying to find the total area, right? So if we found this length, let's first calculate the area of the rectangle, and then how do we find this area? This is just the area of the sector minus the area of the triangle, right? Right. It's not that hard, right? Like this. It's really easy up to A, B, and C. Oh, so it goes up to C. It's easy up to B, right? So, we find the area and the length, but what's the last problem? There's a bit of a problem before we use it, but what is it? What should I say about this? Rainwater. What is RT? Is it the total volume? So, the rainwater that comes in from the outside, is the model for precipitation RT. I think R stands for rainwater, guys. The volume of rainwater, what they told us, guys, is the rate. What kind of rate? It's telling us rate at which rainwater comes into the outer area. Guys. Hey guys, what is RT? It's just the volume. It's the volume of the water inside that outer area. The total volume of the water inside the outer layer. So what is the derivative of that? RMT is the derivative of him with respect to t. What do you get when you differentiate with respect to t, guys? You get the rate of change, right? The rate of change of volume, the rate of change of volume with respect to time, the rate of change with respect to t. That's what the problem told us, right? It told us the rate of change, right, guys? What does the problem say? When you cut it into a 60-second period, for example, if you measured from 1 minute and 10 seconds to 2 minutes and 10 seconds, or if you measured from 5 minutes and 30 seconds to 6 minutes and 30 seconds, no matter which 60-second interval you choose, if that exceeds the total volume of the gutter, what do they say? They say it has overflowed, right? If you measured from 5 minutes and 30 seconds to 6 minutes and 30 seconds, or if you cut any 60-second interval, and if that exceeds the total volume of the gutter, what do they say? They say it has overflowed. It says so, right? It told us the standard for overflow, right? If the amount of rainwater is greater than the volume of the gutter when cut into a 60-second interval, then it's considered an overflow. So that's what they told us. Is that okay up to this point? So what do we need to do first? So what have we done so far? We calculated the cross-sectional area, but why did we do that? This is actually the cross-sectional area of a three-dimensional shape. So now that we found the base area, if we multiply it by 600, we can get the total volume. So when we find the total volume, what are we comparing it to? We're comparing the total amount of rain that fell during those 60 seconds. So how do we find that? Hey guys, check this out. What is this? Look, all wheat, wizard anyway. If we integrate this, we can find RT. What is this RT? It's the volume at that moment T, right? No? For example, if I set R to 60, what does that mean? It's the total amount of water inside that outer shell at 60 seconds. Is this right, guys? So, what is R? It's the total amount of water inside that outer shell at 0 seconds. If you subtract these two, that's the amount of water that fell during those 60 seconds. Do you guys understand what I'm saying? Hey guys, what is this? There's this, in the end, it means that we subtracted the value at 0 from the value at 60. What is this? Since it's the total amount of water inside the shell at 60 seconds minus the total amount of water inside the shell at 0 seconds, this ultimately means how much water and how much rain fell during 60 seconds, right? Do you understand what I'm saying? I just explained why. This is the total amount of precipitation that fell from 0 to 60 seconds. Did you just understand that? So if we say it's from, for example, 10 to 15, then we integrate art from 10 to 15, and after that we plug in 15 and 10 and subtract, right? So it's R at 15 minus R at 10. What does that mean? At 15 seconds, water in the outer shell, minus water at 10 seconds, the precipitation that fell, between 10 and 15 seconds. We use this formula and can calculate it with a calculator. We don't need to calculate the integral from 0 to 60. Is this okay, guys? So anyway, we use this formula, and we can calculate it with a calculator, right? We don't need to calculate the integral from 0 to 60. We just need to see what we get when we calculate this. What do we get when we calculate it? What's the problem? No matter how you define the 60-second interval, if the amount of precipitation that fell during those 60 seconds is greater than the volume of that outer shell, we call that an overflow. If we know the exact starting and ending points of the precipitation that fell during those 60 seconds, we can just integrate art, right? We were trying to figure out how to handle this because of the term n. Is this right, guys? But what is art right now? Hey guys, if we look at art as a function, then finding the area from 0 to 60 is just calculating the area under that function, right? But what is art right now? It's a function that has a certain period, right? Since this is a trigonometric function, what's the period right now? So 2p times 2p divided by 5 gives us a period of 5, right? The period is 5. If there is a certain function, thank you. Guys, if, let's say, period is 2. If I say here that I have this, whether I cut it like this or slightly push it to the right and cut it like this, will the value of the integral change? Will it change or not? Will this integral value change? Doesn't it change? For example, take another look. If this is 1, there's a function, and let's say its period is 2. If I set the interval to 2, hey guys, in this picture, if there's a function with a period of 2, if I integrate fx from 1 to 3 here, if I have this value, integrate fx from 1.1, 3.1, will these two values be the same or different? Think about it. Of course, they're the same, right? Do you understand that they're the same integrating from 1 to 3? Integrating from 1.1 to 3.1 is the same because the area is the same. The same area is being added and taken away. Do you understand what I'm saying? When the period is 2 days, if I take this interval of 2, no matter where I set the area will always be the same. Do you guys understand why I'm saying this? If I try this time, instead of from 1 to 3, I'll set the length of the interval to 4. So if I set the interval length to 4, then it would be from 1 to 5. This time, let me try it like this. Instead of from 1 to 3, I'll set the length of the interval to 4. If I set the length of the interval to 4, then it would be from 1 to 5. Hey guys, what about the integral of fx from 1 to 5? What about the integral from 1.1 to 5.1? It's the same thing. Are you guys understanding this? From 1 to 5, the integral from 1.1, 5.1 is the same. But listen carefully. What about from 1 to 4? What do you think about the integral from 1 to 4 compared to the integral from 1.1 to 4.1, guys? It's not the same. The integral from 1 to 4. The area from 1.1 to 4.1 is different when you go in and out, right? That's not going to work. Do you guys understand what I'm saying right now? In this periodic function for that period, or a multiple of the period, if we're thinking about integration, and there's a function, if that function has a period, then I can set that interval. If you set the interval to a multiple of the period, like 2 or 4, no matter how you cut it, the area will be the same. Do you understand what I'm saying? Why did I bring this up? In this problem, there's this thing called 60 seconds, right? You don't know how to divide 60 seconds, right? But what's the period of this function, which is 60? It's 5, right? 60 is, so that's exactly 12 times the period. Do you guys understand what I'm saying? So, since the function has a period of 5, when we divide 60 seconds, since 60 is a multiple of 5, no matter how I divide that interval into 60 seconds, the values will all be the same. Do you guys understand what I'm saying? So, calculating this integral value, for example, calculating arc from 1 to 60, it's the same thing. So no matter how you cut those 60 seconds, the volume value stays the same. What's the value? It's 180,000. Looking at the value, but that's overflowing because it's larger than the volume of the outer shell.